You said recently tens of billions of robots, but that's decades away.
At least 1 decade away.
It's got to be more than that.
It's going to grow very fast.
Why do you think that?
We're here today to talk about the future of work, the future of industry, and a $10 trillion promise that, quite literally, just hit the floor. In January, Elon Musk made a characteristically astronomical prediction that Tesla's Optimus humanoid robot business would eventually be worth, and I quote, north of $10 trillion in revenue. A figure so large it seems to exist in the abstract, a testament to a future where humanoid robots are as ubiquitous as smartphones. But the future, as it turns out, has a balance problem. Last weekend, at a special autonomy visualized gathering in a Miami Tesla store, Optimus provided a rather different visualization, one not of seamless autonomy, but of a clumsy, water bottle knocking, backward falling pratfall. The video is, frankly, embarrassing. It shows the robot reaching for a bottle, sending its neighbors scattering, and then executing a rigid, graceless descent to the floor, a move we might charitably call the unplanned shutdown. This is our starting point today. The vast, vertiginous gap between the multi-trillion-dollar vision and the current ground-level, quite literally, reality. Over the next hour and 45 minutes, we will dissect this gap. We'll ask, what does this stumble really tell us? How far along are we truly in this race? And who, if anyone, is actually in the lead? Let's rewind and scrutinize the tape. The initial narrative is simple. Robot fails at simple task. But as numerous sharp-eyed observers noted online, the devil, or in this case, the engineer, is in the details. Watch closely as Optimus begins its backward trajectory. Its arms flail upwards toward its head. This is not a typical balance correction algorithm at work. This is the unmistakable signature of teleoperation. It is the kinesthetic ghost in the machine. At the precise moment the robot lost physical stability, the human operator remotely piloting it likely jerked their own arms up, perhaps to grab their VR headset or out of sheer surprise, and Optimus mirrored the movement perfectly. This is the critical revelation of the Miami clip. Tesla has never explicitly stated Optimus is teleoperated in these demos, preferring the term autonomy visualized, but this footage pulls back the curtain. It suggests that what we are often shown as steps toward autonomy are in fact sophisticated puppetry. And Tesla is not alone in leaning on this crutch. Just this week, 1X Technologies opened pre-orders for its home helper robot Neo. Buried in the fine print? An admission that during the initial trial phase, more complex tasks will be handled using remote teleoperation, while its autonomous AI is built out. This is the industry's open secret. The path to true generalized autonomy is a marathon, not a sprint. In the meantime, companies use teleoperation to A, train AI models with real-world data, and B, showcase potential capabilities without having solved the monumental AI challenges yet. The Miami fall wasn't just a balance failure, it was a failure of the illusion. It exposed the human hand, quite literally, guiding the machine. So where does this leave Musk's promise to equip Tesla's own factories with Optimus bots working alongside humans? If a static tabletop retrieval in a controlled store environment requires a human pilot and still ends in a crash, the vision of a dynamic, unpredictable factory floor seems a distant horizon. The stumble in Miami speaks volumes about the years of development, not months, that likely still lie ahead. This brings us to the second, crucial point. To judge the state of humanoid robotics solely by Tesla's progress is to miss the entire frenetic playing field. Because while Optimus was picking itself up off a Miami floor, other players were pushing their machines through far more dynamic routines. The quest to build a truly useful, autonomous humanoid has ignited a multi-billion-dollar global race. And right now, if we're judging by public demonstrations of agility, balance, and hardware fluidity, Companies like China's Unitree are setting a blistering pace. Look at Unitree's H1. In recent videos, it's running outdoors, navigating stairs, maintaining balance after kicks, and demonstrating a degree of dynamic movement and recovery that Optimus has not come close to showing in any public domain. Their smaller G1 model is showcasing impressive dexterity and speed. The hardware itself, the actuators, the balance systems, appears from the outside to be a generation ahead in terms of raw physical performance. The narrative, then, undergoes a significant shift. It's no longer just Tesla is behind its own schedule. It's Tesla appears to be behind in the core physical competencies that form the foundation of any useful humanoid. Unitree's demonstrations suggest they may have solved fundamental problems of locomotion and stability that Tesla's bipedal division is still grappling with. This is a critical inflection point. The first company to couple this level of robust hardware with a truly capable generalized AI brain will have a potentially insurmountable lead. Unitree is showing off the body. The question for them, and everyone else, is how advanced is the mind? And here we arrive at the trillion-dollar caveat, the great equalizer in this race: artificial general intelligence for the physical world. Building a capable body is a monumental engineering challenge, one that companies like Boston Dynamics with Atlas and now Unitree are proving can be tackled. But building the brain, an AI that can perceive an unstructured world, understand ambiguous commands, make complex sequential decisions, and learn from minimal instruction, is a challenge of a different order of magnitude. This is why everyone, including Unitree and 1X, is using teleoperation. It's a tool to bootstrap that AI. Every time a human pilot guides a robot through a task, it generates valuable training data. The dream is to move from shadow mode to full autonomy. But let's be clear about the mountain ahead. For Optimus or any robot to fulfill Musk's factory vision, it must 1. Perceive. Identify a specific bolt, tool, or component amidst visual clutter. 2. Plan. Understand the multi-step process to use it. Grasp, align, insert, fasten. 3. Execute. Perform the dexterous manipulation with appropriate force. 4. Adapt when something slips, is out of place, or when a human walks into its workspace. 5. Learn. Generalize from one task to a similar but not identical task without complete reprogramming. The Miami water bottle fail was a breakdown at the intersection of steps 1, 2, and 3 in a simple scenario. Scale that to a factory. The software challenge is exponentially harder than the hardware challenge. It is the reason why, despite the impressive backflips of Boston Dynamics Atlas for over a decade, we do not see armies of them building cars. So, while Unitree may have a temporary lead in the athletics department, no company has a decisive lead in the cognitive department. The AI race within the robot race is wide open. This is what Musk is betting on: Tesla's edge in real-world AI from its full self-driving project, but transferring that from the structured domain of roads to the infinitely variable domain of human environments is an unproven leap. Let's synthesize. The Miami tumble was not a one-off embarrassment. It was a diagnostic. It diagnosed Tesla's current stage, heavily reliant on teleoperation, with clear deficits in basic autonomous dexterity and balance recovery. It diagnosed the industry state, a split focus between dazzling hardware, like Unitree, and the long, hard graft of AI training, like everyone. And it diagnosed the public narrative, a necessary correction from sci-fi hype to engineering reality. What then are realistic timelines? The pre-orders for robots like 1X's Neo, with their teleoperation caveats, tell a story of incremental, guarded rollout. We are entering the era of the beta robot, deployed in limited, controlled settings to gather data. Mass deployment in complex environments like Tesla factories, that is not a 2025 or even a 2026 story. We are looking at the latter half of this decade, at the earliest, for anything beyond single-task, stationary robotic arms. The integration, safety validation, and sheer AI training required are Herculean. The competition will be fierce. We have hardware specialists, like Unitree, automotive AI crossovers, like Tesla, dedicated robotics firms like 1X and Figure, and tech giants like Amazon and Google, all circling. Consolidation is inevitable. Some will build the best legs, others the best hands, and others the best neural networks. Partnerships will likely bridge these gaps. So, back to where we began. That $10 trillion projection from Elon Musk. Does the Miami fall invalidate it? Not entirely. The potential market, should the technology ever mature, is indeed vast. But what the fall does is recalibrate our sense of time and probability. It underscores that the road from a teleoperated tumble in a showroom to a transformative, autonomous workforce is long, steep, and littered with both mechanical and cognitive hurdles. The hype cycle has peaked. We are now in the trench work phase of the revolution. The race is not to see who can make a robot that doesn't fall over, though that's a basic prerequisite. The race is to see who can first implant a brain into that stable body that can understand and act in our world as intuitively as a human. Tesla's stumble is a vivid reminder that for all the videos, the claims, and the renders, that day is still remarkably far away. The humanoid robot has taken its first embarrassing tumble in the public spotlight. The real question is, how many years before it can consistently pick itself up on its own and get back to work?